Hello and welcome to this new video. In this video, we are going to look at the last aspect of the study focus we've been studying for the last week, earth geometry. We've done a lot of things under earth geometry. We've looked at how to calculate the difference between latitudes, difference between longitudes. We've looked at how to allocate positions or towns or points on the Earth's surface. We've looked at speed in nautical miles, and so many other things that we've looked at. And finally, we're going to look at the last aspect, time differences between 2 points or towns on the Earth's surface. So basically here we're going to learn a skill that can enable us to identify the differences in time or time differences between towns. Let's assume that today it's exactly 7 hours right now. What will be the time in China? What will be the time in America? The time might be different. So it's important we learn the skill to understand how to find the time differences between towns on the Earth's surface. Okay, so the Earth, we know it rotates on its axis from west to east, making a full revolution of 360 degrees in 24 hours. Therefore, every 15 degrees is equivalent to an hour. Okay? That simply means that the whole revolution as it is going to be 360, meaning that for it to be 360 in 24 hours, it simply means that 15 degrees, every time it was turning, when it turns 15 degrees, it will turn 15 degrees in one hour. Okay? That is one thing you have to put in mind. However, we know that the Earth's surface is divided into time zones, or the world itself is determined by the universal timeline, which is the Greenwich meridian. Okay, this simply means that to understand time differences, we focus on the longitude lines. The longitude lines are the ones that can help us to identify the differences in time between points or towns on the Earth's surface. So we are simply saying that this world where we are living in, it's simply divided in time zones, which are easily determined by the longitudinal lines, the longitude lines. The universal time is called the Greenwich Mean Time, which is abbreviated as GMT. So every time I say GMT, I'm saying Greenwich Mean Time. Okay, and we know that the Greenwich Mean Time is the Greenwich meridian. The 0 degree longitude line is the one that is the GMT time. So we know, even in the previous sessions we've been having, I mentioned to say the 0 degree longitude line is the one line which other lines is measured from. So meaning from the 0 degree we can have longitudes on the right side which are heading towards the east, and on the left side which are heading towards the west. And so we know that will simply help us again on finding time differences. Okay, we first of all have to put in mind, if the Earth's surface is rotating, for it to cover 15 degrees, it will be 1 hour. It will take 1 hour for it to cover 15 degrees. So meaning that every 15 degrees moved to the east, when it is rotating towards the east, it simply means that time is being gained by an hour. So meaning every 15 degree turn, an hour, every 15 degree turn to the east, an hour is gained against the GMT. And every time it's 15 degree moved to the west, then that simply means that 1 hour is lost against GMT time. Let me try to see how I can get you cope up with what we're trying to say. Okay, let's hope the ink is good. Okay, let me get a pen. Okay. Now, we are simply saying that 24 hours is what is needed, or that's how long it will take for it to make its 360-degree revolution. Okay? So, this simply means that if we say over 24 hours, so that will give us 1 hour. If we divide 24 hours divided by 24 hours will give us 1 hour. That will be equivalent to 15 degrees. 360 divided by 24 is 15 degrees. This is why we understand that it requires 1 hour for it to make a 15-degree turn. Now, let's try and see how we will convert this into minutes. So we know that 1 hour is equivalent to 15 degrees. So 1 hour is, in minutes, is 60 minutes. Okay, equivalent to 15 degrees. So if we say 15 degrees divided by 15 degrees over 15 degrees, we are simply going to have, okay, 1 degree is 4 minutes. So this tells us that 4 minutes is equivalent to 1 degree. Okay, 4 minutes equivalent to 1. So you need to take note now that 24 hours is 360 degrees revolution, and 1 hour is equivalent to 15 degrees, and 4 minutes, okay, is equivalent to what? 1 degree. Take note of that. It's very, very important that you keep in mind these ratios here. They will help us. Let's look at a certain example that can help us understand even much better. However, we have been given the first question as Alexandra is on longitude 30 degrees east. What is the local time in Alexander if it is 06 hours GMT? So what is the time at the time in the town Alexandra if at the line GMT is 06 degrees? First thing is that I'm going to focus on longitude. My longitude is what? 30 degrees east. So the first thing I have put in mind is it's heading in the east. Remember we said that when 15 degree, when it rotates 15 degrees towards east, 1 hour is gained. So meaning that what I'm having here is that 15 degrees plus 15 degrees, that is equal to the 30 degrees east where Alexandra is lying on. So we know this 15 degrees is 1 hour. So it's more like 1 hour plus 1 hour is equal to 2 hours. I hope you're getting that. But the easiest way to understand that is simply add the degree. So 15 degrees plus 15 is 30 degrees, which is our longitude. So basically what I'm just going to do is the longitude where the town is lying on, which is 30 degrees, should be divided by the 15 degrees equivalent to 1 hour. That is going to give us what? 2 hours. Okay, meaning that the GMT town Okay, the GMT is 06 hours. So if Alexandra is on the east and on 30 degrees, meaning that time was gained. So these 2 hours is representing the time which was gained. So basically, we will now simply say, what is 06? What is 06, okay, hours plus, okay, 2 hours plus 2 hours. So meaning that that is simply going to be 8 hours. Okay? 8 hours. Because of space, I'll just write that. 8 hours. So when it is 06 hours at GMT, Alexandra, which is a town lying on longitude 30 degrees east, it simply means that it will be ahead of time by 2 hours. So if it is 6 hours at GMT, 2 hours ahead on 30 degrees will be 8 hours. Meaning that Alexandra on longitude 30 degrees will actually be 8 hours. Let's look at how, or method 2 on how you can easily understand that concept. So what I've done here is I've drawn to illustrate the longitudes and how the town is on longitude 30 degrees east. So we can see the GMT line is right here, which is the 0 degree line or Greenwich meridian, and the time is 6 hours. So when we are heading towards the east, time is gained. When we are heading towards the west, time is lost. So every 15 degrees towards east, that's 1 hour gained. And every 15 degrees towards west, that is 1 hour lost. So meaning from 0 degrees to this 15 degrees, that is 1 hour, to 30, that's 2 hours. So you are counting the longitudes. From 0, you count 1 and 2, where the town is. That is 2 hours. Therefore, you just get the 2 hours that you found and then add to the given GMT time, which is indicating 06 hours there. So 06 hours plus the 2 hours will be 8 hours. However, if Alexandra maybe was lying on 15 degrees west, meaning that 06 hours, 1 hour will be lost. So we're going to subtract the 06 hours minus the 1 hour, and then it will be 05 hours. Let's look at how to get the time differences in this particular scenario here on example 2. Washington is on longitude 77 degrees west. Okay, 77 degrees west. What is the relationship between local time in Washington and GMT? So as simple, we just get the 77 degrees. 77 degrees is where it's lying on. So to understand the time difference, we'll divide by 15 degrees. That will be 15 into 77 is 5. 5 time is 5 time is what? Time is 15. That is going to give us what? So the remainder is going to be 2. Okay, the remainder will be 2, because we are simply saying that, yeah, so 77 degrees divided by 15 degrees is 5, remainder 2 over 5. So how do we get this kind of difference? So we can see that this is the time difference, but now we have a fraction. That simply means that we are dealing with minutes. So this 5 here should represent hours. Okay, and this fraction here should represent minutes. Okay, should represent minutes. So let's see how we can do that. So we're going to write 5 hours. Okay, we're going to write 5 hours. Now, how do we get the minutes? Let's look at this. So we have 2 over 5 in fraction, which means these are minutes. Therefore, we know these minutes is out of what? The 60 minutes, which is 1 hour. So this is going to give us 6 times 2 is 120. Divide by 5, that is going to be 24 minutes. Okay? So we're going to simply say it is going to be 5 hours, 24 minutes. Time difference, or the relationship between Washington, which is lying on longitude 77 degrees with the GMT time. Okay, so let's try and see if we can attempt questions from the past papers and allocate time differences questions, then attempt them. When you have a problem, just capture the question, send in the group, and I'll get back to the question as soon as possible. That is basically how we can calculate the time differences. If there are any questions, please feel free to ask, because this means that we've come to the conclusion of our topic F geometry before we start the new one. If there are no questions, then I will assume people have clearly understood. If there are questions, it simply means that people have understood, but we still want to learn more. So if you have any question, feel free and ask, and I'll get back to you. Have a blessed day, and thank you for watching.